And I think now we can pass it over to John Scott, who's going to give us his STMD's power and energy storage roadmap and gap closure plan. So John.
Thanks, Chris.
Yep.
Can I be heard?
Yes, I can hear you, John.
Oh, okay, very good. I think Andre or someone's going to put up the slides.
Yes, sir.
Okay, very well. I found that my internet connection where I am was failing, so I'm joining you through my magnificent iPhone. So I hope I can be heard clearly.
You sound very good.
Apologize for the delay. Okay. Okay. Well, what I'd like to do this morning for the workshop is take the opportunity to explain where wireless power transfer fits into NASA STMD's technology strategy, particularly for the moon. All right. Why don't you go to the next slide? To give an overview for those of you who are not already familiar with it, NASA's technology strategy is formed around a strategic framework where we divide up what technologies need to be developed to support each aspect of NASA's mission. We've got 4 thrusts: go, land, live, explore. And each of these have outcomes associated with them. Our STMD's job is to develop the technologies from whatever TRL they are to practice to support these outcomes associated with each mission thrust. Go to the next slide, please. Okay, okay, well, I'll go from here. Within the live thrust, there are a number of outcomes associated with the lunar surface, how to live on the lunar surface. And key to these, one of the key outcomes that we have to have is to have a sustainable power transmission system. There are 2 gaps defined in our roadmap to reach that goal that have to do with power transmission. There's cable power transmission and wireless power transmission. And the system becomes a trade-off for those 2. Why don't you go to the next slide? There's a number of applications for lunar surface power transmission, transmitting from, say, a remote fission power plant to a habitat, et cetera. But the killer app, I'll call it, the one that's most challenging to us is how to get power down into the permanently shadowed regions where we suspect there's mineable lunar ice available to us. That requires, from our current studies, that we maybe have to deliver up to 40 kilowatts, and that's an extreme case, from a source that's in the sunlight on the crater rim up to 10 kilometers down into a permanently shadowed region to support ISRU operations. Those large numbers come from not from a prototype scale that you've heard a lot about, but from an industrial production scale operations. We think that's about as big as it's going to get into that level. The amount of power, the power production that's being done on the ridge is quite a bit larger. But again, we might have up to 40 kilowatts or 30, 40 kilowatts that needs to be delivered down into the crater remotely. Let's go to the next slide. This amounts to a system trade between wireless and cable transmission. You can see on my chart here, we've got a definition of what those systems are. That includes the conditioning at each end of the power transmission, the transmission means itself, and various other balance of plant. That's the total system. So from that, we think of 2 figures of merit for power transmission. There's the percent of delivered power, the percentage of loss in delivered power over distance, and then there's the delivered power transmission system mass per unit mass. So you have a specific efficiency, if you will, with distance, and a specific power with system mass. We need to know what those figures are in order to make a system trade. The transmission trade down the bottom of the chart is rather straightforward. We may have an application where you have to beam down to a rover that's down in the crater. That would be a beam solution, and they'd have to track a rover going around and down in the crater at these distances. Another option is to either with a beam or with a cable go to a fixed station that's down in the PSR, and from that station you might have a beam to a mobile system, to a rover, or you might have the rover going out with the energy storage aboard and coming back to the station to recharge. So which of those ends up having the best figures of merit which of those is the best architectural solution depends on how the solutions compare within these figures of merit. So why don't you go to the next chart? Okay. Okay, so the gap that we have in mind for our roadmap is for wireless power transfer. And we'll have a similar gap for cable power transfer, is that, transfer of tens of kilowatts over up to 10 kilometers distance at X% loss per kilometer and Y kilograms, Y kilowatts per kilogram of system mass. And we need to have something for that by tutorial 6 by 2028. So, but my charge to this workshop, the question I'm asking is that I want this workshop to tell us for the current state of the art, what's X and what's Y, and what X or Y and Y could we get to by 2028? And then what type of investment, what direction would need to be done to achieve that? We're asking the same question of people proposing cable transmission solutions, but we're asking that question of wireless power transfer. And that's basically the charge of this workshop. We need to know what those top level figures of merit can realistically be expected to be. So that's I've done that really quickly, but so Wes, I'll take some questions.
Sure. So reminder to everyone, you can use the Q&A in the Q&A function to ask questions throughout this time as well.
Yeah, and Wes, I'm not going to, because of my pitiable internet capability, I'm not going to be able to read that. But
okay,
so
yeah, when they come in, I will read them too. Yes.
Tell me. Okay. All right. Right. So that's a real brief way of asking the question, but I like to see what the question is. I think I can see one come up on my iPhone. Can you read what the question is, Wes?
The question that came up was from someone from the audience already, so that's already been answered already.
Oh, okay.
But we can hold on just one second. We can look at some of the topics that we've got covered, and see.
In the chat.
Oh, it did come in the chat. I just see the Q&A, so maybe here it is. I have a question for you. If 20 to 30 kilowatts electric are needed in the crater, what are you imagining the scale of power generation is outside the crater?
Whatever it takes to get that amount per the system mass. And again, that will factor into the overall architectural trade. If you need 100 kilowatts on the or 200 kilowatts on the crater rim to get to the bottom of to get the 30 kilowatts, say, to the bottom of the crater, well, that becomes part of the overall system trade. But again, to factor that in, that's why we need to know the efficiency, the power loss per unit distance. That's the figure of merit that figures into that question.
Yeah.
The rest of it is the mass. Yeah, and we'll deal with the mass of the power generation system on the crater as well as part of the system trade. But what we need to know about the transmission system is that the efficiency loss, if you will, percent delivered power loss over distance.
Sure, and that was asked by Don Jenkett from NREL.
Okay.
So just to give him some credit for that. He'll be speaking tomorrow too, so I'm excited to hear more on that conversation too. So yeah. I'm going to grab some more questions from the chat as they're coming in. So there's a question: are you considering Y as evenly split over the transmitter and receiver?
I don't think I'm considering it either way. You tell me.
Yeah, yeah. I guess that's open for that. Okay.
We're talking end to end, like in the graph. If you put the chart that shows the two system diagrams, we need to look at that end to end. So where the losses take place is not that relevant. Now there is an interesting second order effect here that I sort of allude to down in the. If you'll show the chart with gap closure for wireless, the chart before the one that you're showing now, but that is so everybody can see it. There's down the lower right-hand corner, there's a surface diagram on a particular path for one of these PSRs of how close the straight line might come to the surface, and we could be in a situation where, depending on how much the beam a beam spreads out, you might have it impact the surface and reflect, kick dust or reflect back up into the rest of the system, and that could have an effect on efficiency. So again, that's like a second order effect. We would probably ideally try to find a solution to where the beam never does impact the surface between the transmitter and the receiver, but it very well might. So that's something that have to be considered. Again, I think that's a second order problem.
Yeah, and that's something that we can get some information from our partners in dust mitigation as
Right.
well.
Right.
Yeah, and that'll depend on modality and other aspects of the trade too.
Again, that might be a trade between which PSR and which path you want to use, cable versus wired versus wireless.
Lots more questions coming in now, so I'll try to capture as many of these as I can and compile them together if possible. One interesting question is, what's the willingness to pay for a 40 kilowatt wireless system?
The willingness to pay for 40 kilowatt, you mean 40 kilowatts delivered?
Yeah, I think that's what I would interpret it as.
Willingness to pay.
Yeah, so if this is all sort of, how do you envision, this, I guess maybe another way to ask it might be, what's the priority of this in, say, the funding structure that you have to achieve this?
Okay. Yeah. Okay. Well, this gap, closing this particular gap, and I'll speak about it in those terms, is going to compete with the closing of other gaps. And at this point, I cannot tell you how important this gap will be to close versus the gap of having the solar power generation system on the rim. Mm-hmm. Again, the one thing I can say is that we're looking at trying to have a production capability after 2030. It may not go that fast. How fast we go there will depend on how much commercial capital there is to build the production system. The priority now, depending on what our assessment of that will help set the priority of when we need to have a prototype available. Mm-hmm. And that's really what the TRL6 is for, because this is something that will have to be tested on the lunar surface before we can call us ready for prime time and scale it up for production. Yeah. Again, and that first prototype may not be at that 40 kilowatts delivered. Probably won't be. It'll be more like 10 or single digits. Mm-hmm. But again, the idea is that it may not be obvious to the extent to which that will be scalable up to the 40.
Sure. Here's another question from one of our speakers coming up pretty soon, Paul Jaffe. So
hey, Paul.
Yeah. So loss per kilometer from end to end perspective rarely scales linearly, and so right. he's asking if you can maybe further discuss the rationale of using this as a figure of merit, or maybe if the call might want better key performance parameters or something like that.
Well, again, this is a first order simple-minded way of looking at it. I'm sure Paul's correct. It isn't linear with distance necessarily. It's probably got a square. But you tell us. I mean, what should it be? We need to account for how much a given solution loses over the transmission distance.
Yeah, and to that point, this is one of the questions that is addressed explicitly in the breakouts on day 2, when we can have more of a technical discussion. So yeah, I'd really like to see maybe some thought given to or input from the community on what those how those figure of merits could be more better constructed.
Yeah, I put these out there to start a conversation. I do not presume that these are the be all end all figures of merit. It was the first order to get the conversation started. If we can define something more appropriate, then I want to hear about it.
Sure. That's great. And so we're going to try to get to that. So I'm going to move over. There's still quite a few more questions coming in. So Alan DeLuna asks, so far you seem to have focused upon central production with trades between transmission systems. Right. Where's the trade for central versus distributed generation? Rover self-powered.
Okay. Yeah. Well, again, it's not on this chart. I mean, that is part of the question, certainly. And again, within the trade space, there's always the idea of having the power generation down in the crater. I mean, it's not that seems to be a very challenging problem. You got to land something. Are you going to land a fission reactor down the crater? Mm-hmm. The people involved in that just pale at the challenge of doing that. But that may work out to be the best way. Especially if these figures of merit, whatever ones we end up with, make the business of transmitting so many kilowatts into the crater look impossible. You know, it may work out that way. Then that will drive up. It's a multi-level trade. It'll drive up to a higher level trade about where maybe we need to try generating power in the crater with a nuclear solution.
Mm-hmm.
You know, that's I guess the thinking at the moment is that it should be possible to get that kind of power delivered down to the crater from the rim. Maybe it'll look better to try to land that reactor in the crater. You know, it can always heat itself, right? So
yeah. You've got
of course there's communication problems too. You got to have line of sight communication to somewhere, and you may not have a satellite. You'd have to have a satellite to rely upon, you know, to be able to do that. So it's it gets to be a very interesting problem.
Yeah. Here's a question with respect to the modalities. Are concentrated solar, microwave, laser, and maser beams still under consideration?
You tell me. And again, you got the first order idea. Yep. And we need to transmit wireless. Okay, what spectrum? Well, which one performs best against the top level figures of merit for the range of power and range of distances we're talking about?
Yeah, and that's something which appears actually in both of the breakout sessions, the trade between modalities. So interesting in hearing if we can come to some consensus about which one is ideal, and maybe I'm sure we'll hear from the speakers as well today on that.
That's why I framed the question this way. I'm not picking a winner among those at all.
Yeah,
I don't think we're qualified to do that right now.
Great. Gary asks, Gary Barnhard asks, the top level of figures of merit are starting point, the technical trades that are required to determine the viability of any potential element of the solution space is more involved. Where do you see this being addressed?
Well, again, you know, we need to know what we can count on for a system trade. Now, another part of the question that was on my last chart is that what does it take to deliver that capability?
Yes.
You know, there's some development efforts. Some are riskier than others, and you know, that's, you know, if, you know, once the agency or STMD decides how much priority to put on and funding to put behind closing this particular gap, as opposed to all the other gaps we have, all right, then it's a discussion of, okay, what's the most cost-effective way to achieve that performance, and you know, what does that development program need to look like?
So there's a lot of questions which I think will fall into some of the more technical discussions as well, and I'm going to try to pick ones that you know, we can you could hopefully address well. Okay. So there's
how am I doing so far?
I think we're doing well. You know,
I'm trying to get the community thinking in a certain way.
Absolutely,
that, you know, and is the idea is that, you know, here's the basic problem we're trying to solve is this. Okay, now you know what's the range of solutions? You guys tell me. I don't want to assume I don't have a clue. Yeah,
I think that this is perfectly in line with how this workshop is meant to go. We start very broad. We generate a lot of conversation and discussion, and then we, you know, try to address these points that everybody comes up with along the way.
Very well.
So some questions about, you know, is there an early estimate about the relative weighting in the trade-off between X efficiency and Y power per mass?
No. I don't think we're smart enough to even do that. Again, that'll probably work up. I mean, you know, once we get this determined for a wireless system, we're going to have these equivalent figures of merit determined for a cabled system, right? And again, you know, then you launch into the, okay, how does the rest of the system trade out?
Yeah.
And you know, it'll, you know, what the efficiency metric will tell us is how much power we have to be generating up on the crater rim. All right, and that will feed into how much of that we have to launch to get on the crater rim. All right, that's what that will feed into. The specific mass of the system itself. Well, again, my guess was that would be less of a driver than this efficiency loss, but I don't know that. It depends on how bad it is. It depends on how it looks.
I'm looking here. Go ahead.
For example, if the specific delivered power per unit system mass of the transmission system exceeds that, or is lower, I should say, I'm sorry, no, I'm wrong. It's worse than that of the power generation system. Well, then I think that would drive the solution a certain direction.
Mm-hmm. Mm-hmm. Yeah. So early hints that as much as we can before we construct the full system.
Right.
Yeah.
Right.
There's some questions about. Let's see if there's a lower limit that could be considered useful. So is there an upper limit to the received aerial power density, either due to thermal or RFI instrument limits? That I think is probably going to be addressed with more technical talks.
Yeah. You tell us. I mean, if you're
Yeah.
going to have a, that's that probably works into the efficiency and the system mass.
Yeah, and I think we will get to those points. And then the other counter to that question is there a lower limit which could be considered useful?
Lower limit of what? Of total power delivered?
Mm-hmm.
We could probably say that. I mean, if it's much less, if we end up with less than a kilowatt down in the hole, it's probably not going to do us much good.
Mm-hmm. Well, there the trade comes in. Yeah, there it comes more. I get you that in that trade space, you're coming up against RTGs as well.
Yeah, that's how much power it is, but what the solution is.
And how much? How many of those RTGs we can have available too?
Well,
everybody wants that.
Plutonium's kind of hard to come by.
That's right. Okay, I'm seeing if there's a few more questions that have come in. I'm trying to find which ones will be appropriate for us here. So there's a question, does the efficiency include the initial conversion to laser energy? I think you already said that essentially yes, where you want end-to-end consideration for efficiency. But maybe this is something that we could piggyback on that. You know, end-to-end product doesn't have to be all from the same, provider. To what degree are you considering, sort of pairing different solution options that could be proposed?
Oh, okay. Well, again, that top level trade diagram I have there. Mm-hmm. That's, I say that, like the transmission, I'm presuming, or making assumptions here, be explicit of what they are, that if we're trying to go straight from the rim to a mobile asset down in the hole, that's going to have to be beamed. Okay. Mm-hmm. You're not going to drag the cable around. Okay. Mm-hmm. Yeah. But, going from a combination solution is essentially what you're talking about. Have a cable or beam go down to a charging station, and then maybe it's beamed from there or recharging from there. That's trying to capture the concept of what we're talking about, the path of power from the source to the load. Very well could involve two different solutions.
Yeah, I'm even thinking, sort of you could have different receiver and transmission solutions.
Sure. Yeah. Well, yeah. Again, it's the idea of having a charging station, if you will, down in the crater is a version of that. Mm-hmm. Get power to the station, and then from the station to whatever asset needs to be mobile. And again, you think about, well, how mobile can it be? Does it need to be? And that will feedback on how mobile can it be within the mass limits we have.
Yeah, and this is a question that's come up before: is can we come up with a figure of merit that is something like mobility per mass? So we're covering it in that sort of way.
I thought, I was thinking about that in building this chart. It doesn't seem to. It seems we would, again, just for the group in general, I'm involved in writing the rules for the Waltz on the Moon Challenge, mm-hmm. and we're going round and around on things like that. And I think the thing to do is keep it simple. That's a difficult thing to do. I mean, basically the presumption is if it's mobile, if you're trying to power something while it's moving around and your power source is not, then that's got to be a beam solution. Mm-hmm. Just assume that. And again, whether that's a better, the trade-off there is that a better overall system mass than having the mobility asset have a battery and then come back to the station to be recharged. Mm-hmm. How does that, which one has the most efficient or the least impact, or least negative impact on the mobility that you have?
Good. And a comment in the chat from Jeff Landis that he doesn't think there is a lower limit, Mike, for that would be useful. micro rovers that could use as little as 20 watts of power. So,
Oh yeah, yeah.
Yeah.
He's right. It's just that the killer app here I'm talking about is ISRU production,
yeah,
or at least prospecting.
Okay.
You know, I'm sure you could run a science rover, you know, with some instrument for a lot less power than that. Absolutely, but yeah.
These are also, you know, I want to make sure that we give time so that we can transition to the next talks. But one thing that I feel, you know, very heartened about is that these questions and these topics are all more or less well aligned with a lot of the topics that we'll be going over in the breakout sessions.
Yeah.
As well as other information that we'll be getting from the rest of the focus group leads, who I believe are coming up next. So we
Okay.
probably maybe one more minute if you want to say a final word about this before we transition.
Oh no, I again, I appreciate being given the time, especially I appreciate you accommodating my pitiable support today. I got double booked or triple booked actually, and I'll admit that part of my being a little bit tardy is that I'm on Mountain Time. My laptop's on Central Time, and you're on Eastern, and I had a transform problem.
Well,
I was actually sitting in a meeting. I thought I had another hour, but you realize no, you don't.
Well, your wireless solution saved you in the end. So
it absolutely did. I mean, you know, the Wi-Fi in the hotel room's a joke, but my iPhone works beautifully. But no, I created this presentation as a way to give a charge to the workshop that from the top level view of trying to define a gap for the technology program and an idea of how to close that gap. This is what we need. I mean, some idea about these two figures of merit. And again, the fact that they're not linear, well, that's part of how you define the figure of merit, right?
Mm-hmm.
And if we can come out with something we can hang our hat on and use for our strategic planning out of this workshop, that would be great.
Great. Thank you very much. I think that's a perfect way to end our first session.